Hey everybody, we're back again. Morgan here. Electrochemistry lectures, page 8 of 12. Now, this is one big question here that I originally designed to look like an old-fashioned AP question. So what I'd like you to do is pause the video and then go and try and do this, and then start the video up again when you're done, and we're going to see how you've done with it. Okay, welcome back. Hope you had a good time with that. All right, so the first thing that I'm doing here, acknowledging 25 degrees Celsius, standard conditions, that's my reaction. I need to find the half reactions. Fe is turning into Fe2 plus 2 electrons, and Cd2 plus 2 electrons is giving me Cd. Okay, so I go to my table of my EMFs, all right, locate the Fe2 plus 2 electrons to give me Fe. That is a negative 0.44. I've reversed it, so I have a positive 0.44 volts. Now let's find the cadmium one, okay. Hopefully it's on this page. It may not be. It's a rarer metal. Here we go. And that's going to be a negative 0.40. Negative. So overall, I have 0.04 volts as the EMF for that reaction. Now, to calculate the delta G naught for this, I go minus NF E naught, which equals minus, let's see, I've got 2 moles of electrons, times the Faraday constant, 96,485 coulombs per mole of electrons, times 0.04. Now, a volt is a joule per coulomb. So coulomb cancels coulomb, and this comes out to be, in joules, negative 7718 joules. So that's the equivalent of about 7.7, negative 7.7 kilojoules. Positive EMF with a negative delta G, that goes hand in hand. Cool. What's the equilibrium constant expression for this reaction? KEQ equals, on the top I have Fe2 plus divided by, and on the bottom I have Cd2 plus, and the cadmium and the iron are not going to be included because they're solids, but the ions will be. Okay. Numeric value for that, the ln of K is equal to N E naught over 0.025693, which equals 2 moles of electrons times 0.04 volts over 0.025693. And I can just kind of forget about the units, because once I get into doing a logarithm, the units are just not relevant anymore. Okay, run that through your calculator, and K comes out to be about 22.5, which has no unit. It is dimensionless. Okay, all right, so now I'm going to set it so that the iron 2 is that concentration, cadmium 2 is that concentration. E equals E naught minus 0.0592 over N log of Q, which equals 0.04 volts minus 0.0592 over 2 times the log, and that 2 comes from the 2 moles of electrons that are moving around. Okay, so I know Fe3 plus goes on the top, and the Fe3 plus is 0.010 molar. This is 1.0 molar. And when I run that through my calculator, I get 0.099 volts. Okay? Now, let's think about this. A very low concentration of iron and a higher, like factor of 100 times more concentrated CD2+. Le Chatelier's principle tells us that reaction is going to go forward. And this is a positive E. Okay, in fact, it's even a little bit bigger than our original. That's 0.04 volts. And I could probably even round that off to be 0.10 volts. Okay, that's an agreement. That sounds good. Now, what if I did the opposite? E equals 0.04 volts minus 0.0592 over 2 times the log of, and by the opposite I mean this time the iron is going to be 1.0 molar and the cadmium is going to be 0.01. So 1.0 molar, 0.010 molar, and this time this equals negative 0.019 volts. So non-spontaneous, because I've got too much product and not enough reactant. Okay? Now, looking at G, part G, I want to find delta G, not delta G naught, just delta G, okay, which equals minus NFE. So for this combination where the iron is 1 molar, okay, which is what we have here in F, this equals negative 2 moles of electrons times the Faraday, 96485 coulombs per mole of electron, times the negative 0.019 volts, okay, moles of electron cancels, and a coulomb volt equals a joule, and this comes out to be about 3666, or about 3.7 kilojoules. Non-spontaneous and a positive delta G. That works out just the way I want it to. Okay, thanks for tuning in, and we'll be right back with page number 9.